What is the theory of relativity? The theory of relativity is a theory developed by Albert Einstein that revolutionized physics. This theory states that the relationships between time, space, and mass are relative, and that physical events can differ depending on an observer's reference system. The theory of relativity is a theory that is valid at high speeds and large masses, unlike the macroscopic world where classical mechanics and Newtonian physical laws are valid. The theory of relativity has radically changed the understanding of classical physics and led to a new physical paradigm. This theory, which is especially valid at high speeds and in strong gravitational fields, has played an important role in the field of modern astrophysics and cosmology. Additionally, the theory of relativity has played a major role in understanding technological developments such as the atomic bomb and nuclear energy. The theory of relativity is a subject that is still actively studied and researched today, and is a fundamental theory that profoundly influences our understanding of physics. Two important components in the theory of relativity. The theory of relativity is a theory developed by Albert Einstein that revolutionized physics. This theory states that the relationships between time, space, and mass are relative, and that physical events can differ depending on an observer's reference system. The theory of relativity includes two important components. 1. Special theory of relativity. Special theory of relativity examines the relationships of fast-moving objects with time, space, and mass. This theory posits that the speed of light is the fastest speed of the universe, and that time slows down for a fast-moving observer. Special theory of relativity states that the concept of simultaneity in time and space depends on the motion state of the observer, and that time periods can change according to the speed of the observer. Moreover, this theory is also known by the equation E equals mc squared, which shows that energy can be converted into mass and mass can be converted into energy. 2. General theory of relativity. General theory of relativity explains how objects under the influence of gravity bend and affect space and time. This theory shows that gravity causes space-time to warp, and these warps affect the movement of planets and the overall structure of the universe. The general theory of relativity uses a system of equations of curved space-time to determine the motion and position of an object in a gravitational field. This theory offers Einstein's new understanding of gravity and explains Newton's law of universal gravitation in a broader context. The theory of relativity has radically changed the understanding of classical physics and led to a new physical paradigm. These theories are valid at high speeds and in strong gravitational fields, and have played an important role in the modern field of astrophysics and cosmology. The theory of relativity is a subject that is still actively studied and researched today, and is a fundamental theory that profoundly influences our understanding of physics. Some evidence for the theory of relativity. The theory of relativity has been supported by much experimental and observational evidence. The theory of relativity has been confirmed by experiments and observations made by many scientists, especially Albert Einstein. Some important evidence for the theory of relativity. 1. The speed of light is constant. According to the special theory of relativity, the speed of light is the same for every observer, regardless of the observer's state of motion. This theory suggests that electromagnetic waves travel at maximum speed in a vacuum. Many experiments and observations have confirmed that light travels at the same speed for any observer. 2. Expansion and compression of time. The special theory of relativity proposes that a fast-moving observer will experience time slowing down. This theory states that particles traveling at high speeds live slower and last longer. This phenomenon has been confirmed in experiments measuring the lifetime of fast particles. 3. Gravitational curvature. According to the general theory of relativity, gravity causes an object to curve space and time. This means that the path of light traveling in an object's gravitational field is warped, and the gravitational field of stars and planets bends the path of star rays, displacing images of stars in the sky. This phenomenon was observed by Arthur Eddington in an experiment during a solar eclipse in 1919, proving the accuracy of the theory of relativity. This and many other experimental and observational evidence have confirmed the validity of the theory of relativity. Today, the theory of relativity is considered a cornerstone of modern physics and has been successfully applied in many different fields. However, like every scientific theory, the theory of relativity is constantly tested and supported by further observations and experiments. I will tell you about the movie Interstellar, which is one of the most interesting works on this subject. Interstellar is an epic science fiction film directed by Christopher Nolan and released in 2014. The film attracted attention with its complex storytelling without compromising scientific accuracy and visual spectacle. Focusing on the theory of relativity, this film explores how time and gravity are affected. Subject: the film is about humanity's search for a new place to survive due to agricultural disasters and drought around the world. Joseph Cooper, Matthew McConaughey, is a farmer turned former NASA pilot. After a series of events, Cooper and a group of astronauts join the spacecraft called Endurance, which is sent into space in the hope of finding a habitable planet for humanity. Theory of relativity. 1. Effect of time. During their missions, astronauts realize that the time they spend in space is different from the time they spend on Earth. This is based on Einstein's theory of relativity. Astronauts discover that as they get closer to a planet and its gravitational pull increases, time slows down and there is a big difference between the time spent on Earth compared to a clock orbiting that planet. 2. Black hole and space-time folds. Astronauts experience the effects of the theory of relativity by observing how time and space curve while orbiting Gargantua, a black hole. This area is one of the places in the film where time is more dramatically affected. 3. Travel in different dimensions. In the film, the more speculative aspects of the theory of relativity are also discussed as astronauts travel to different dimensions and parallel universes in space. This shows how time and space are affected in a more complex way. Conclusion: Interstellar uses the theory of relativity on a scientific basis, providing audiences with a visual experience to understand complex topics. The film is considered a masterpiece in the science fiction genre, focusing on challenging issues about the nature of time and space. It offers an unforgettable experience to science fiction lovers with its visual effects, music, and in-depth story. Dark is a German science fiction television series created by Barenbow Oder and Jansch Fries. It was broadcast in a total of 26 episodes over 3 seasons between 2017 and 2020. The series tells a complex story around time paradoxes, parallel universes, and family secrets. Main plot: the series centers on the events between 4 families living in the small German town of Winden, the Nielsen, Tiedemann, Doppler, and Conwald families. The story takes place across multiple time periods, spanning a broad timeline from 1888 to 2053. Key elements. 1. Time cycles. Dark emphasizes that time has a cyclical structure. Time repeats in a continuous loop, and characters have the opportunity to intervene in their past and future. This is linked to the theory of relativity's flexibility and changing flow of time. 2. Parallel universes. The series focuses on parallel universes as well as time. Characters in different time periods discover how their decisions and interventions can have different consequences in parallel universes. 3. Mystery and family secrets. Dark deals with complex relationships and deep secrets between families. How the characters' past actions affect future events, and the events that unfold as family secrets are unraveled present a great mystery to the audience. 4. The role of time. The theory of relativity deals with the concept that time can be an illusion and how time can change depending on the way people perceive time. Dark questions how time is integrated into the characters' lives and how it can affect their own pasts and futures. Conclusion: Dark is considered a series that needs to be watched carefully because it has a complex structure. The theory of relativity, time paradoxes, and parallel universes add a science fiction and mind-bending atmosphere to the series. It invites viewers to understand the fragile nature of time as the characters try to unravel their secrets.